Welcome everyone, my name is Denise and I'm going to demonstrate the Interactive Process Drift Detection tool. This tool, also named IPDD, provides an interactive and visual process drift analysis. The tool is available online and you can start it here. And the first step is to upload an event log. For this demonstration, I'm using a public dataset containing process drifts from different change patterns. Each event log contains 9 process drifts. The user should drag and drop the event log here, and then IPDD will upload it. After the uploaded has been completed, IPDD shows the name of the file here, and the user can click on it. And then the next step is to verify if this is the correct event log, check the initial traces, and then the user can go to the process drift analysis. Here you can see the main window of the tool, where the user can change the parameters to start the analysis. The idea is to read the event log, in this case trace by trace or event by event, and then the tool will split the event log in windows or sublogs. In this case, the analysis will split the event log in windows containing 250 traces. Then start the analysis and follow the status here. And this is the output of the window. For each window containing 250 traces, IPDD mines a process model and provide the interface for the user to check the models over time. So here the user can zoom in and zoom out the process model and visually understand or identify a drift. In this event log, we can see that after 250 traces, 2 edges are added and then removed, and then added again. If the model of the current window is not similar to the previous window, the tool identifies this window as drift, indicated by red. And here on the left, the user can check the information about the drift, which causes the drift. So in this case, it's an edge that is added, 2 edges in fact. They are listed here. The current implementation of the tool calculates 2 similarity metrics, the edge similarity and the node similarity. In this example, the edge similarity metric identifies the drift. Of course, the window size is a tricky parameter which affects the detected drifts. So the idea is the user can interact with the tool, change the parameter, and explore the process drifts using different time slots, so different window sizes. Here you can see the same event log using a different window size. The user can still verify the drift, and of course this provides the user the freedom to explore the event log using different parameters. Now I'm gonna use another file from the same public dataset, but in this case the event log contains an activity that is changed. You can see the new uploaded event log. Click on it. If everything is okay, then go to the process drift analysis and set the 3 parameters. Read the log as a string of traces, split the log trace based on traces, and use the 250 window size. In this case, the process models are not similar because there is a difference in the node similarity. If I zoom in to the model, we can see that there is an activity that's replaced. The replaced activity is added and the verify repayment agreement is removed. When the user is applying the process drift detection tool on an artificial log like this one, it is possible to evaluate the detected drifts by informing the real drifts here using the trace index. So in this event log, we know that there are 9 drifts on these traces here, and then the tool can calculate the F-score. The F-score metric is based on the true positives, and false negatives. For instance, if I remove the last drift here, the tool detected drift was not informed by the user. In this case, the F-score will no longer be 1. Here the user can hide this evaluation panel and change again the parameters. The idea is to explore different window sizes to understand the dynamic of the process model over time. Here you can see the same model and the change. Of course, if I use a parameter that is too large, in this case, if I set the window to 500, I will not be able to detect the drift because the drift occurs after 250 traces. In this case, all the process models are the same and we have the both activities here. This is the idea. To solve the issue of defining a good window size, we provided an interactive user interface where the user can explore different values and understand the dynamic of the process. The source code of the tool is available on GitHub. You can download it and check. And you can also extend the tool because this tool is a prototype implementation of a more generic framework, which is described here. And it is possible to include new process models or new similarity metrics for the detection. So please feel free to try it. If you have any problems, you can contact me. Thank you very much.